Of another Leetcode problem, 1639, number of ways to form a target string given a dictionary. So for this problem, we are giving a list of strings of the same length of words and a string target. So we can check this one. So we are giving a array words, and inside words it is the same length. So for example, this is ACCA and with BBBB and CACA. So this is just for the words. And we also have a target, and this is target. And we want to find some sequence. So for each of the column, so yeah, we're gonna choose the character from the column inside the words array. So we can turn this 1D array into a 2D array. So for the first column, for example, we're gonna choose a letter A from here. And then the second column from here, we can choose a letter B. And then for the third column, we cannot find B maybe. We need to find A. Yeah, but at the fourth column there's A. So we just need to find the sequence ABA, and then this is a valid search. We want to find how many valid searches there is. Maybe this is not clear. Let me just copy the characters, and you will see it clearly. Let's just prepare the strings. So first, this one, and let me make the alignment. Because for this problem, we need to prepare some strings like this. First of all, turn this 1D array into like a 2D matrix like that, because this is more clear. And let me prepare some empty string, and we just want to see the alignment more clear. So for the first of all, we're gonna choose from the first column. We're gonna choose a letter, so the target is ABA. So we're gonna to find a match with the target ABA. So first of all, in this column, the first column, we can choose A. There's one A. Or we will not choose it. We're gonna start from the second column. So let's try this example. I'm gonna choose A from the first column, this A, and then I go to the second column. I can choose this B, and then I go to because in the third column there's no A, and then I go to the fourth column. I can choose this A or that A. So there are two cases. Or we can do another case. So let me clear it. Or maybe we want to choose from the second column. From here we're gonna choose A, and then from the third column we can choose B, and then the fourth column we can choose two A's. So there are another two solutions. Or maybe we can find others. Maybe from the first column we're gonna use this example, ACCA. Let me just clear it. Or from the first column we're gonna choose this A, and from the second column we can choose this B, and from the fourth column, I think I've already quoted this one. So this is a 0, 1, 3 from ACCA, and 0, 2, 3 I've already quoted. Now let's check this one. So from 0, 1, 3, so from here, I think I've already quoted from the index 1. And then we're gonna check from the second case from here, the index 0. There are 6 cases, but sometimes if you want to count it, it's really difficult. But if you program, it should be easier. But the idea is that. So let's try this one, ABA. So from index 0, we're gonna choose A. So from ACCA, we're gonna choose this first. Let me clear a little bit. So from here we're gonna choose A, and from index 1 in this BBBB we're gonna choose B here. And then from ACCA we're gonna choose A. And from this one we're gonna CACA, we're gonna choose A. So there are 2 cases. Let me use another color just to make it a little bit more clear. Now we're gonna still choose this A from here. And then choose a B from here. As you can see, the red color. And then we can choose A from here and here. It is at the fourth column. So there's another 2 cases. And the third one, we're gonna choose A from here. Yeah, let me just use the maybe use another color, maybe use the blue one. Yeah, so we're gonna choose A from the second column, and then choose B from the third column, and then choose another A at the fourth column. Yeah, as you can see, there are another 2 cases. So in total, there are 6 cases. But why did I do that? So this is just for solving the problem. So for solving the problem, it is just like a DP problem. So from the first column, we're gonna count how many A's, because our target, the first character is A. So from the first column, we're gonna count how many A's. So there's 1 A. Yeah, so we're gonna continue search. We have decisions to decide whether we will choose characters from the first column or not. Yeah, so this is like a DFS with memorization. So we can decide to choose this A, or we decided not to choose. If C is choose and N is not choose. Yeah, if we decided to choose this A, and then the target will be pointed to B. So for the second column, we're gonna decide if we are going to choose B or not. If we are going to choose B, yeah, this C still means choose. We're gonna choose a B. Yeah, and then we're gonna go to the third column. We want to find another A. There's no A, and then we go to the fourth column to find if there is a, yeah. So this is a not choose, and then we go to the fourth column to find if there's A or not. How many A's? So there are 2 A's. So we're gonna choose A. Yeah, we're gonna choose. And how many? So this is C. So this is a valid path. And because there are 2 A's, so 2 times this valid path. So this means there are 2 ways. Yeah, I'm not sure if you are. Yeah, because for the DFS, we can decide to choose or not to choose. But if we decided to choose, we're gonna decide how many characters of this A, or how many characters of this B, or how many characters of this A. Because basically, this is a valid path needed to time the numbers of the characters. Yeah, so this is just a basic idea of how to solve the problem. Yeah, now let's go to the code editor to finish the coding. As I said, I'm going to prepare this DFS. So for the DFS, I'm going to start from this I and J. So the meaning of DFS is just how many numbers of this kind of chosen characters from each column to let the result becomes this target. We just need to check how many numbers. So I is starting from 0. I is just for each of the column. So for example, we have 4 columns because there are 3 rows and 4 columns. Yeah, so for each of the column, this I will decide if I want to choose a character from this column or not. And this J is just the length of the target, starting from 0. We're gonna try 1 by 1 until go to the end. We're gonna decide if our chosen result is ABA or not, if it is this target or not. So this is the meaning of DFS of this INC. Yeah, normally this is a dynamic programming problem. So we're gonna use a case. Now we're gonna start the DFS. Yeah, let me call the DFS first. So the DFS would be starting from 0, and for the J, it is also starting from 0. Yeah. Now we are going to check this I. So yeah, if let me first check this J, because J is the length of the target, is this one. Yeah. Yes, but before that, let me prepare some variables. So I'm gonna use N as the length of the words 0, N is the column, and M is the length of the words. So N is the number of rows. Yeah. Now I'm going to check this J, the target. Yeah, and if J equals to, let me use the length of the target as M. Yeah, because I wanted to check if there's a valid result or not. If J equals to M, this means if J equals to the target. Yeah, so if J equals to the target, it means for this example, it means if z equals to 0, 1, 2, z equals to 3. If z can go to 3, it means we've already found a result. Because if there's a valid for this a, z will plus 1 go to the next, and for this a, z will plus 1 go to the next until it goes out of the boundary of the target. Yeah, so if this z equal to m, I'm gonna return 1. Now, if z not equal to m, yeah, but I equal to n. Normally the I is the column. For this example, it is 0, 1, 2, 3, but it cannot be 4. But if it is 4, because n is the column, length of the column, yeah, if I equal to n, it means there's no valid result. I'm gonna return a 0. Yeah. Now we're gonna start the main part of the DFS. So how can we check that? Yeah, so now for each of the column, we can decide whether we're gonna choose it or not. Yeah, but here we cannot use the brute force to count how many A's or how many B's or how many C's. Yeah, for example, this is A, but there are 26 characters. We have to count it one by one. If we use brute force to count one by one, so this is I and Z. So for this I and Z, the time complexity is n squared. If we were to use another loop, it is another n. It is n cubic. That is not possible. So we cannot use a for loop to count how many characters in each column. So what are we gonna do? We have to prepare a DP. Yeah, so for this one, we still need to prepare a dynamic programming. So this is just to count how many characters at each column. So for example, this is A. So for this is just to count how many characters at each column. For example, in the first column, how many A's, how many B's and C's? There's one A, one B, and one C. We want to prepare a DP counter to count it in O1 time. Otherwise, this cannot pass. It means from here, we cannot use for loop again because it will already be n squared. The time complexity must be n squared times 26, not n squared times 1000. Yeah, so this is why we're gonna prepare a DP array. So this DP array is just a counter, is to count how many characters in each column. So for example, in each column, in the first column, how many A's, how many B's, and how many C's. Yeah, let me first run it. So inside of the DP array, it's gonna be 0 times 26, because there are 26 characters. We're gonna count all of them. So for I in reads, and yeah, how many columns? So n is the column, so it is in reads n. Yeah. Now we're gonna prepare this DP counter. So how can we prepare it? So for let me use R. Yeah, as just the enumerate. So for RW in enumerate the words, and for C, yeah, I will use I and Z because I want to use a C here as my character. So for Z, C in enumerate the W, this word. Yeah. Now I'm gonna count it how many characters in each in each column. So because because this J is the column, as you can see, this J is enumerate the word. The length of the word is 4. So from here it is a DP J, and I need to calculate which character it is. So I need an odd with the words. Yeah, so inside of the words, it should be row and column. So I is the row and J is the column. Yeah, or you can use this word directly. It should be W and J. Yeah, because W is the word and WJ is the character of this character. Yeah, we need to find this kind of a character, and this odd should be minus odd A, because I'm starting from 0. This is inside the DP array. 0 just means A. Yeah. Let me make a comment of this area and just print out the DP array. Just we need to check what it looks like. Yeah, we just need to make sure our DP array should be right. Otherwise, later on we have to debug. I want to make sure the DP array is okay. As you can see now, it is not okay. It is always 0. It should not be 0 because I didn't finish writing the DP array. Yeah. So this one should plus equal to 1. Yeah. So this is for each of the yeah. Let me check. So dpi is for each of the rows, and this odd wj minus odd a. Yeah, this dpj is for each of the rows, and this one is for each of the column. Yeah. Now let me just run it to check what it looks like. Yeah, as you can see, it seems okay. Yeah, because this one gonna be the first row. Actually, it is the first column of here, of this ABC. Yeah, here may be confusing. Sometimes it always depends on how you gonna define the column and rows. So for this first row, actually, there are 26 characters. From the beginning, it is always 0. Now, we are sure at the first column, we have 1A, 1B, and 1C. At the second column, we have, as you can see from here, yeah, we still have, yeah, from the second column, as you can see, 1A, 1B, and 1C. Here, we still have 1A, 1B, and 1C, if you see it from here, yeah. So it seems that it is okay for our DP array. Yeah, so this DP array is just a counter. We're going to use it to count how many characters of A, B, C until Z in each of the column, because I'm going to use it later. Now I will use this DP array. Now let's continue the problem. Yeah. So now I have two decisions at each of the column. I can decide to choose it or not choose. So the result would be equal to 0. If I were to choose it, so result should be plus equal to DFS with this I should plus 1 and J would plus 1. So this means I want to choose it, but I need to times a counter. It means yeah, in this column, how many characters? For example, this is the first column. Yeah, for example, this is the first column ABC. For this first column, let me use a white color. Yeah, for this first column ABC, how many characters of A we want to check? Yeah, basically we're gonna check how many characters of A, and we need to time a counter. So this counter is just DP array, so it is a DP I. Yeah, because this I is for each of the column. So the definition from here, this I is for the column, and we need to time with, yeah, so the DPI should be second with characters. So the characters should be odd with target with this J, because from the beginning J is 0. Yeah, and it should be minus odd with character A. Yeah, so this means how many characters of A, because for the first one, if we decided to choose it, we need to decide at the first column how many A's. Yeah, and we can also have another decision. We will not choose it. Yeah, so if we will not choose the first column, so we're gonna start from the second column. So for the yeah, I should start plus 1. I should still need to plus 1, but for this J, it should be fixed. Yeah, Z should not move forward. If we decided to choose, Z needed to move forward, and we needed to time a counter of this DP. If we decided not to choose, so I should still plus 1, because I needed to shift to the second column, for example, from here. But for this J, it will still be pointed at the first position at this A. Yeah, so this is why. Now, let me just have a check if it works. Otherwise, we have to optimize. Yeah, so there is a none. For this DPI and Z. Yeah, let me just have a check. Yeah, normally I believe I solved it a few hours ago. Normally I can solve it again, but sometimes if this problem is hard, we have to check it. So if I equal to so if this I equal to n, or if this j more than m, we're gonna return a 0. This j just means basically this is j. If it is equal to m, it means we've already found one. If this is j, I don't know. So I think I have to check my previous submissions. Maybe, I also submitted a lot of time limited, and I also passed a lot of time. But it seems I have to check my previous code. Let me just check what is wrong with it. So this is the DPI odd with target minus odd A, and J plus 1, and I plus 1 with J. It seems similar, but I don't know why. It seems okay. I think it's exactly the same code, but sometimes I don't know. I didn't prepare the modular. I forget about the modular. Let me prepare the mod. 10 to the power of 9 plus 7. But the idea is just like that. So this is a DP with I and with odd target J. Here I used variable J, and here is the same, minus odd A. DFS I plus 1 with this J. And I forget to return. This is why. Because this is a DP solution. I prepared the result, and finally I need to return it. Normally I think I can, while I'm doing the problem, normally I should not forget about it. But sometimes while preparing the problem, maybe I forget about it. I think it should be okay. Now as you can see, it works. And for the time complexity, because this is a case, this is n square, and for this one, it is just O1 time. So from here, this is n square. But for this DP array, it is n squared times 26. So it is still a small number, because 2.6 times 10 to the power of 7, it is still less than 10 to the power of 8. So in Leetcode, if it is more than 10 to the power of 8, it will be time limit exceeded. But for this one, it is less than that. Normally it can pass. And I think this one should still be a good solution. Because for the time complexity, it is n squared times 26. Now let me submit it to make sure everything works okay. I forget to modular the mod. Let me submit it again. Now as you can see, at least it works. It is not so fast because this is not tabulation of DP. This is a DFS plus memorization, because here influences the time. But here I used this J minus M. I think this J equals, while this J equals to M, I have to decide whether this J should plus 1. If I find a valid solution, do this J need to plus 1? If this J already more than M, So my idea is that z should never more than m. Yeah, because from here, if z find a valid solution, if z equals to m, it means I've already found a valid solution. I can never more than m, so I don't need this line. Yeah, let me just make sure. Yeah, as you can see, it works. So this means from before I used this one, actually I don't need it. Let me just submit it. Yeah, as you can see, it works. I think this one should be a better solution. It is not what I solved before. So what I solved before, like from here, yeah, I also checked this k minus m, this j minus m. Actually, I don't need to check that because it will never happen. Yeah. Maybe we can, yeah, save some line of code, but it not looks so good. We can also return like this. Yeah, dp dfs plus a dfs. We can save some lines of code. Yeah, I'm not sure if this looks more clear or not, but we can save some lines of code like this. Yeah, and let me delete these areas and submit it to check. Yeah, this is just for saving some lines of code, just make it more clear. Yeah, it seems that it is a little bit faster than before. Yeah, so thank you for watching. See you next time.